This is what's new in RecurDyn V9R5. And the sections that we'll go through today will first cover some of the GUI enhancements, and then we'll go through solver enhancements, and then enhancements to multi-flexible body dynamics. And then lastly, we'll go through the improvements to the various toolkits. So one of the main enhancements in the new version is that RecurDyn models can now be saved in a text format file. And so the benefits of this is that when they're saved into the XML file format, these files are more readable and archivable. They can be easily edited. They're also more stable than the binary file format. And the model can be examined and prepared for simulation without using a license. And also what we call the RDX file, which is the main text file, it can be used directly in batch mode simulation. So users can go ahead and just use a text editor, edit certain parameter values, and then just feed it right into the batch mode simulation. There is a certain organization of how the files are saved out, and the main information is saved in what's called the RDX file, and then there's some different hierarchy and data files to store the other information. And then there's another set of files to store the CAD information, which is stored in a binary format file, which is actually using the Parasolid format. And then for flexible bodies, these are saved into also some of them as text format, which would be the Nastran BDF format. And then for other types of information, some of those are in binary format. Another nice enhancement is the new design experiment capability in RecurDyn. And so one of the main advantages here is that you can now choose to run some of these well-established DOE sampling methods. And so before, the full factorial method was available, but now we have all these other different methods, like the Plackett-Berman central composite design. And so these types of designs will help to cover the sampling space without as many trials. So this will reduce the time that it's required to run all the simulations, but you'll still be able to establish trends from the experiment. In general, there's also improved graphical user interface design just to make performing all the tasks easier to do. And there's also a new simulation manager feature which will automate the runs of all the trials in parallel and in sequence. And also there's some convenient data handling features, which allows for the import and export of the DOE tables and results files into CSV format. And this just shows the simulation manager feature. And you can see as after the user clicks on this start simulation button, it'll go ahead and run through these multiple simulations simultaneously. And then as it finishes those up, it automatically kicks off the next simulations. The next enhancement is the UV smooth contact surface generation. And so if you don't know what the UV surface is, it's something in RecurDyn where you can take a four-sided surface, and then RecurDyn will sort of split it up into sort of a mesh or grid pattern, and then it'll do some special interpolation to make contact with that surface very smooth. And so this is something that has been in RecurDyn for a couple versions. And the enhancement in this version is that there's now a utility to create your own UV surfaces. So you don't have to use only a four-sided surface. You could start with something maybe 5 or 6-sided here. So in this example, there's an extra side here, and then this utility will allow you to specify a set of edges to represent one side of the UV surface. And then you can also ignore holes within the surface. And then once you create that surface, then that will allow you to get smoother results. So this is the before UV surface creation. You can see that there's a contact force arrow that as the ball rolls across the surface, the contact force arrow is a little bit noisy just because there's some tessellation of the contact surface going on behind the scenes. But then after we create the UV surface creation, then we can see that the contact force is much smoother because there's the interpolation going on to create that smooth surface underneath. There's also been enhancement to the marker trace feature. And so this is a way for users to view the path that a marker traces throughout a simulation. And then the enhancement here is that before, here's an example where we can see the path of that the marker takes. However, it's with respect to the global reference frame. So because this marker is attached to one of the suspension components, we just basically see the long path that it takes across the terrain. But if we want to see the path that the marker takes, maybe like as far as the vertical motion of the suspension with respect to the car, then we can now define a local reference frame attached to the car frame. And that's shown here in this dialog. We can specify the reference marker for the marker trace. And then once we make that change, we can play the animation. And the marker trace in this animation is now shown in pink here. And it's showing the vertical motion of the suspension with respect to the car. The next enhancement is ProcessNet support for Python. And we'll be going into this in a little bit more detail later, but just to briefly go over some of these benefits. Python is a scripting language that is now supported along with Visual C# and Visual Basic. And users can create Python scripts using their own Python IDE. And then once they create those scripts, they can be run from the RecurDyn main ribbon menu. They can also be automatically started when RecurDyn starts up, and they can also be run from the Python IDE. And a nice advantage also is that you can also run it from a DOS command prompt or as part of a script. So basically you can now start ProcessNet ProcessNet scripts from outside of RecurDyn, which is a nice enhancement. And this diagram kind of just shows some of the different ways that you can initiate a ProcessNet script using Python. And then this animation just shows an example of some of the things that you can, some of the automated tasks that you can do with a ProcessNet script. The next enhancement is to the RecurDyn plotting of the Campbell diagram. So this is what the diagram looks like. And there's now a phase angle display. And so this is sort of a cross-section of the contour plot that's shown in the main window here. And then there's also a Vold-Kalman filter that's been added. And so this filter helps to smooth out some of these results here that initially are very noisy. So once that filter is used, the results become much smoother. There are also some enhancements to RecurDyn Post. And one is that a 3D plot has now been added. And so this is what the dialog boxes look like. You can define the X, Y, and Z components of your curve. And then the plot will then look like this. And also the Campbell diagram is now added to RecurDyn Post. Some more RecurDyn Post enhancements are that there is a series information utility. And this is similar to the trace data tool that's available in the regular plotting environment. So when you use this tool, then you can put your mouse over a certain point on the curve, and then it'll display all this information about the current point, as well as some information about the whole curve, such as the minimum, maximum, and the average, the root mean squared value, and other things. Another nice enhancement is that you can now copy and paste curves to other plots. And so how that's done is you can just right click on a particular curve and say copy to clipboard, or you can just type the Control-C on the keyboard. And then once you click on another plot, then you just click Control-V to paste that curve into the new plot. There are some other GUI enhancements are that there's an enhancement to the force display. And the enhancement here is that there's now a button or a checkbox here for each force, which determines whether or not you want to see that force in the modeling window. Before, you had to sort of delete the force from the list, and then if you had to add back in, then that was a little bit more of a process to go back and find the marker. So this just makes it a lot easier to switch the force displays on and off. There's also, in the expression window, the highlighting of parentheses in the expressions. So as you're typing in the expression, some of these expressions obviously can get very complicated and can have many parentheses. So as your mouse, or as the cursor sort of enters a parentheses or passes over one, then the matching parentheses will be highlighted to make it more clear what how the expression is being entered. Okay, so the next items we'll go through are the solver. And oh, I am getting a question here. There was a question about a plan for contact with UV surfaces, and if it's going to be expanded in the future to cover things such as spheres and points, cones and torus. So the answer to that is actually that there are already some analytical contact types in RecurDyn where it'll recognize primitive geometries such as cylinders, cones, and toruses, and then it automatically just uses the parameters of those shapes to perform the contact. And so there's no tessellation required. So this is kind of something that's already in RecurDyn. All right, so to go through a little bit more of the enhancements, we're now talking about the solver enhancements. One enhancement that a lot of users have been asking for is that you can now activate or inactivate bodies. So before, it was users were able to deactivate forces and joints, but now you can also apply this to bodies. And when you do this, then that particular body will be ignored by the solver during the simulation. And it will also be grayed out in the modeling window. So if we can take a look. Okay, so here's an example of a simulation where these gears and the shafts on the left side are included in the simulation, so we can see them turning as expected. And then what the user can do is they can select different bodies from the database window. They can also select it from the modeling window as well. But here we can see once they've made the selection, then you can right click and there's this inactive option. And so once they select that, then if they run the simulation again, we can see that these bodies are not really part of the simulation anymore. They're grayed out and they're also not moving. And then when the user chooses to activate or reactivate the bodies, RecurDyn will automatically enable all the forces and joints that were connecting that body to the rest of the model. The next enhancement is to the geo contact. And so this is, the enhancement is how the contact handles contact with 2D shell elements in flexible bodies. And so there are certain situations where the shell elements have a varying thickness. So in fact, the thickness defined at each node can be defined individually. So that's what we're showing here. If you're to bring up the properties for a particular element or 2D shell element in this mesh, you would see that the thickness defined for each of these nodes has its own value. And that's used to represent certain geometries where the wall thickness varies. And the enhancement is now that the contact within RecurDyn takes that thickness into account correctly. So if we take a look at this simulation here, we can see that the solver is handling that thickness correctly. The next enhancement is the addition of the calculations for kinetic, potential, and strain energy. So for rigid bodies, kinetic and potential energy are available. And then for flexible bodies, strain energy is also available. And so we can take a look at this example here. The spring has been modeled as a flexible body. And so as this simulation runs, we can see the variation in strain energy. Obviously, the kinetic and potential energy of this top body are also changing as well. So applications of this enhancement are that you can predict which bodies will store the most elastic deformation energy, and those bodies might be the ones that might be more susceptible to failure. So the engineer can easily identify those bodies. This also helps reduce vibration and noise in the system. And then it can be used as a way to validate the simulation results through the conservation of energy. The next enhancement is that friction has been added to screw and in-plane joints. And this is what the dialog looks like. You can now include friction for the planar joint. And if you click on this sliding restriction button, it'll bring up the different friction parameters that you can adjust. And once you add friction, this is an example here of two planar joints where the blue cube is connected with a planar joint that has no friction. And then for the green cube, friction is turned on. So then as this large surface tilts in different directions, you can see that the friction is working on this planar joint connecting the green cube. Another nice enhancement is the cyclic spline. And so this is, what we're seeing here is the spline dialog that we're all used to seeing, where you can enter points and represent a curve. And then now the enhancement is that there's a new option to the extrapolation type. Whereas before it was linear, quadratic, and cubic, now there's a cyclic option. And then what will happen when this option is selected is that it will automatically repeat, the interpolation will repeat the curve. Once it reaches the endpoint, it will go back to the first starting point or the first endpoint and repeat the curve. So this just makes it more convenient to represent things such as periodically changing input signals or repetitive motions. Another enhancement regarding expressions is that there is now this EXP VAL function. And this basically makes it really easy to include the value of expressions within other expressions. So in this example, we have one expression on the top, which has a certain waveform. And then we have a second expression representing another waveform of a lower frequency. And then our third expression is simply adding those two expressions together using the syntax shown here. And then when that expression is plotted, then you can see that it does that addition correctly. So this is nice because this was possible in the previous versions, but there was certain extra entities that you had to create. And now this is all just quite easy to type in to the third expression there. There also is now on-off control for the C motion constraint, or I guess the C motion group constraint. This constraint is kind of a specialized, well, I guess maybe a general constraint where you can actually define the constraints for each of the 6 degrees of freedom individually. So this is a nice thing to use if you have some kind of situation where some of the standard constraints, such as revolute or translational joints, don't really meet the needs of the situation. So the enhancement in V9R5 is that you can now control whether the constraint is active using an on-off expression. And so the way it works is that if the value of the on-off expression is 0, then the constraint is off. But if the value of the expression is 1, then the constraint is on. So in this example here, this top plot shows the on-off expression, which is kind of just kind of pulsing up to 1 during certain parts of the simulation. And then the bottom plot here is showing the rotational speed of this driven shaft. And the constraint that's being implemented by the C motion group is the basically constraining the rotation of these 2 shafts together. So if I just I'll go ahead and play this animation, when you can see as the on-off expression is turned on, that it is then constraining the two shafts to rotate together at the same speed. Then when the expression turns off, then the rotational shaft is slowing down due to friction or whatever other forces are on it. Okay, so the next enhancement is user-defined plot output, and for the RPLT file generation. And so users can basically choose what entities within the plot output they want to save. And so this is nice because sometimes for certain kinds of simulations, the RPLT files can become very large. And so the user can easily select a subset of the results they want to see and then free up the data storage for both the RPLT files and then the plot files. And the process of how they do that is shown here. You can start with your original RPLT file, and then you can use the regenerate result files utility. This is the utility that will actually let you choose the subset. Actually, it's shown. Oops. It's shown here. And then there are 2 options. They can either, so once that utility is used, it'll generate the new user-defined RPLT, which is a smaller file. It'll also generate a CSV file containing the same data, and then it will generate an output list, which is kind of saving the list of all the outputs that the user had chosen. So then if they want to repeat that process with another RPLT file, they can use that as input when they do that the second time. And this animation just shows how that utility works. So they're choosing our RPLT file, and we can see all the different entities. And so this is showing a nice filter where they can, feature where they're filtering the results by text input. So it's going to select any plot output that has that TMTX, that particular text pattern in it. And then they've generated the new RPLT file, and it can be used just like the old one. And then this second animation will show the second option, where we're basically reusing the previous selection using the output list file. So the user would just select that option. They're going to select a particular output list, and they click the run button, and then the reduced RPLT file has been generated. And again, now all these outputs are available to plot. All right, so the next set of enhancements have to do with multi-flexible body dynamics. The first one is an enhancement to the FFlex thermal analysis, where we can now model convection with surrounding fluid. So in CFD software such as ParticleWorks, users can perform a thermal fluid analysis to obtain the heat transfer coefficient and the ambient fluid temperature at the surface nodes of the mechanical system, including the surfaces of flexible bodies. And then once you have those results, they can be applied into the RecurDyn simulation, and that will then allow the simulation to consider the conduction, both the conduction within the flexible body as well as the convection with the surrounding fluid. So if we take a look at, we would first start out with the ParticleWorks simulation here on the left, and we're calculating the heat transfer coefficient. And then we would bring those results into RecurDyn, and then you can see this is a contour plot of the temperature, and we can see how this particular body is being cooled by the fluid. So this is nice enhancement for certain applications, such as if you're doing an analysis of gear dynamics, you can see how high temperature gears are cooled by oil. And another enhancement is a new feature called vibration shape, which is a post-analysis. And so what you would do is to first run a normal dynamic or kinematic simulation with an FFlex or RFlex body, or both. And then what happens, all right, so that's, for example, this is a flexible clutch plate diaphragm spring in a RecurDyn simulation. And then what RecurDyn does is to then it will measure the displacements of the nodes specified by the user in that they want to include in the post-analysis using a user-defined patch set. And then it does an FFT analysis on the X, Y, and Z displacements of all of these nodes. And then it also calculates the frequency data and then generates a vibration shape. And then once that post-analysis is complete, then the results are will look like something like this, where you can view the results of the FFT analysis and identify your different peaks. This first peak is one of the main modes, and then you can identify the other modes. So this will help engineers to understand the influence of vibration on the system by being able to visually see the vibration shape. The next enhancement is the FLEX node-to-node constraint. And so what this is if it's an easy way to connect two separate meshes at a common face. If you have two FLEX bodies that you've meshed separately, and that if they sort of connect or meet each other at a common face, you can just easily create this constraint without the meshes having to match up at that face. So you can have different element sizes and or different element types also. And this node-to-node constraint will connect the meshes without any extra meshing having to be done. And it acts like a glue contact where the flexibility is maintained through the connection. So some examples of this, if we can start here with this 2D shell element mesh, and then if we have another 2D shell element, then we can basically just create this constraint by first defining the nodes where you want to make the connection, and then you create the constraint itself. Here's just another type showing that you can connect solid type and shell type elements together. And then here's another situation where if you have large elements in one mesh and smaller elements in another, you can easily connect those together at this shared face. There have also been some enhancement to the FLEX mesher. In the advanced mesher, there is something called seed control. And so this is something where you can basically define the number of elements that you want to have on particular edges. So this would be kind of the initial mesh before you make the use seed control, and then after you use seed control, you can specify the number of elements on all the edges to obtain a more consistent mesh. There's also an enhancement to the meshing of beam elements, and the enhancement is that it will now generate evenly spaced nodes along an edge to provide better results. So if we start out with a particular edge geometry that has certain vertices in the middle of the edge that are not evenly spaced, in the previous versions of RecurDyn, RecurDyn would always use those vertices as node positions, and so then the resulting mesh would have uneven lengths for the elements. But in V9R5, this new feature will create the nodes evenly spaced. There have also been enhancements to the RFlex input files. There's some features to optimize the file size. So often if you have a very complex mesh representing your RFlex body that has many nodes and elements, or also included modes, then the R5 file can be very large. And in addition to the file size problem, there's also animation performance issues where the animation is a little bit slow. So the R5 file optimizer solves these problems by allowing the user to choose a subset of nodes to save the data for, and retain the data for. And some of the options that they can choose from are to only save data for the external nodes, or the used nodes that are used for joins and forces, or they can also make their own custom selection of nodes to save the data for. So as an example, we've got a fairly complex RFlex body here that has over 1 million nodes, 870,000 elements, and 112 modes. And so then with the stress and strain information included, the RFI file is 10 gigabytes. But then if you use the optimizer, you can select a subset. There are these different options to reduce the file size by excluding certain information that might not be necessary. And then there's also the choosing a subset of nodes that you want the data saved for. And so with the option where only the external nodes have data saved for it, then the RFI file size becomes 4 gigabytes, which is a 60% decrease. And then they can also choose, in this example, they've chosen a subset of the nodes, and file size is further reduced by 90% to 1 gigabyte. There's an enhancement to the RFlex body animation. And the enhancement here is that the user can now select which modes they want to have included in the animation, and that will help increase the speed of the animation. There's also now RFlex support for the solid element anisotropic material type, which is equivalent to the Nastran MAT9 card. So now users can model anisotropic materials in their RFlex bodies to represent reinforced structures. There's also another enhancement for the user to be able to visualize the stress strain curves for different types of FLEX material definitions. And so these are some of the available material types are hyperelastic material types and also plastic material types. And so now there's this new button here where you can click on the draw button, which will bring up this plot that will allow the user to visually see the stress strain relationship. And likewise for the plastic material types, you can see that type of curve as well. All right, so now we're going to go over enhancements to the particular toolkits in RecurDyn. There have been some enhancements to the drivetrain toolkit, and one of them is an improved KISSsoft gear train creation. And the improvement here is that previously it was only possible to define a gear train where the gears are in a sequential order, as shown here. But now you can, using the new dialog controls, you can define the gear pairs individually. And so this opens up the possibility of defining more complex types of gear trains. And so these are just some of the examples here showing what can be modeled now. We can now model single and double pinion gears, as well as some of these other examples. And so this is now useful for certain types of applications such as E-axles and limited slip differentials. Some more KISSOFT interface enhancements are that the new version of KISSOFT, which is 2020 SP2, is now integrated into RecurDyn. And so all those new features are now available in RecurDyn as well. In addition, KISSOFT's planetary gear module file, which they call Z14, is now supported. So that's available in the interface, through the interface. So planetary gears can be created by KISSOFT and then can be read into RecurDyn. And then also, if you create a planetary gear in RecurDyn, then it can be read and modified in KISSOFT with these particular controls where you can import, export, or just bring up this interface here. So now with this addition, there are now two buttons in their interface, where the Z12 button corresponds to the existing gear train capability, and then Z14 now will bring up the new planetary gear capability. And there's also enhancements to the KISSOFT post features. The enhancement here is that there's some new data that can be output. You can now output sliding velocity contact pressure, which is the Hertzian contact pressure at the contact point, and pressure velocity, which is the multiplication of the contact pressure and the sliding velocity, and also output of the contact points. There's also an enhancement to the standard particle interface. The enhancement is that there's now realistic fluid surface rendering. So when you're viewing the results of RecurDyn, of a RecurDyn ParticleWorks co-simulation, it is now possible to view the flow of the fluid particles using a more realistic rendering. And so if we take a look, this is kind of the representing how the fluid surface is displayed more smoothly. So initially when you view the particles in RecurDyn, they'll appear as what's shown on the left. Once you apply this new fluid surface rendering to the fluid, then you get this nice visualization of the fluid. And so we can see a couple examples of animations using this new rendering feature. And then here's just another example. All right, so next enhancement is enhancement to the media transport toolkits, both to the 2D and 3D versions. The enhancement here is that multiple markers can be defined to be detected by an event sensor. So what they, the user would click on this mark list button, and then that would allow them to input a list of markers for the sensor to sense. And then when the simulations run, as this sheet progresses through the system and passes by the sensor, the sensor output will cumulatively increase with every time the marker every time one of these markers passes the sensor. So this basically makes it much easier for users to track the progression of a sheet body past a particular sensor. There have also been enhancements to the control toolkit. The enhancement here is the addition of the RecurDyn host mode to the general co-simulation. And the reason for this is that because the general co-simulation tool is the only one that supports multiple co-simulations. So you could have a co-simulation between RecurDyn and maybe 2 or 3 other softwares at the same time. And in the past, RecurDyn, or I guess the general CoSim didn't support this, the RecurDyn host mode for Simulink. But now that it does, then when users co-simulate with multiple other softwares, Simulink can be one of those softwares. So that's just showing here now that RecurDyn is available as the master program here. All right, so that pretty much covers all the enhancements in general for RecurDyn V9R5.